My name is Piotr Pasich, and I'm working as a senior software developer at X-Team company that is mostly in Australia, but most of our clients are in on the West Coast in the US. So that's all about me that you need to know right now. I have been working with blockchain technologies for last about 2 years or something like that, and I have to admit that a lot of things really surprised me, even if I had like a strong background with financial projects before, like the banks or exchange systems within the internet or something like that. But still nothing similar to the blockchain and integration. Moreover, when I started working with the blockchain during my first project that I'm going to talk about in a minute, we struggle for a lack of knowledge. Because these days, if you ask me what the blockchain is, my general knowledge about that would finish on a single sentence. That is, the blockchain is just a chain of the blocks. But if you ask me what the chain is or what the block is, I would definitely quote Kimi Räikkönen from the Renault Megane advertisement, where he said, "I have no idea." So I started to read a lot of articles about the blockchain itself, how it works, how to develop that, and I have found a huge lag between the articles of knowledge, between the articles about the financial prospects of the blockchain, how to invest into the blockchain and not lose your money, and really deep knowledge, how it works, how the mining works, proof of concept, proof of work, and others, proof of work concept, proof of history, proof of work, and other binary options work. But there was a lack of knowledge in between, how to integrate, how it works, what do you need to take care about when you integrate with the blockchain, what do you need to take care about if you are working in a financial project that operates on the blockchain. So that's basically what I will talk about today. And I find this topic really interesting because a lot of companies or a lot of clients are still asking for blockchain developers who can integrate with the blockchain, not to create a new one. But believe me, if you integrated 3 or 4 applications with the Bitcoin, Ethereum, EOS, or other blockchains, you will be probably able to write your own, because even these days, a couple of companies are going to publish new frameworks to build new blockchains. That was announced during the Money 2020 conference a month ago or something like that. There will be a couple of frameworks available for you for doing such a things. So, some time ago, I have started, one of our clients came to us and asked us to finish and develop and maintain an ICO project. ICO is an initial coin offering, which works basically like an initial paper offering on the stock market. When the company wants to open themselves and fundraise some money from the investors, they go to the stock market, and during the very first day, they sell their stock to the investors. That's basically how the ICO works, but instead of the stock papers, you sell the coins. But, so, my knowledge about the coins, about the tokens, about the Bitcoin, Ethereum, and other blockchains was limited. So I started digging up, and I have found that the blockchain, or the Bitcoin itself, as a very first implementation of the blockchain, was introduced in 2008 in the yellow paper, published by an individual or an organization called Satoshi Nakamoto. We still don't know who he is. And he claimed that his idea of internet cryptocurrency or the internet currency should be based on full anonymity. Nobody should be able to read your data, your personal information from the blockchain. It should be fully secured because it's still all about the money. It should be owned by people, not by any organization, individual, or central government. Nobody owns the money or the ledger. The ledger is owned by the users who actually use it. It's all about the financials, so the heart of The blockchain or the ledger at the very beginning was the transaction, financial transaction, but right now it's mostly about storing and sending a piece of information. And that's it. And in January 2009, a couple of months later, the very first block from the blockchain was published. But what is block? So, as I said, the very heart of the blockchain is the transaction. So, the transaction can be defined as sending money or some assets, data information, something like that, from one user to another. But how we call it in the blockchain, if you have a full anonymity provided by it, by the technology, it is basically the transaction is moving some kind of information from one address into the another. But even with this description, you cannot provide a full anonymity. So you basically send from some generated address or generated set of addresses to another auto-generated set of addresses. And that's a huge deal if you compare that to the banks or to the like PayPal payments. But I will talk about that in a minute. So if you send a transaction within the blockchain, the other thing is how to actually confirm that, how to say that a single transaction is inside the blockchain. So you are waiting for another transactions for the next, in the Bitcoin representation is for next 10 minutes. It's an approximation time because the first thing that I was surprised in the Bitcoin was that they claim that every block is mined every 10 minutes, but that's not true because the next block can be mined in the next 40 minutes, and after that you will receive another block after 2 minutes, and after 2 after 2. So you can wait even for an hour for the next block, and then you will receive 6 blocks in 1 minute. That's how the blockchain might work. So if you put a couple of transactions into a piece of paper, you can just write it as a block. A single machine or a single organization can confirm that the block is okay for them, and all the transactions or the assets on the accounts or the addresses are secured, and they can confirm that. If you would like to push there another transaction, you need to put it on another piece of paper, which will be confirmed after that and after that. So every block has is placed after the previous block and is stored with a special hash that confirms its authenticity. Thank you. So that's basically it. If you would like to integrate with the blockchain technology, that's everything what you need to know. Nothing about mining, nothing about how it works internally, but what the blockchain block is, what the chain is, that the one block comes after the another, and how to get the transaction, nothing else. So, with this little knowledge, I started digging how to compare that with whatever I knew from my previous work, from my personal and professional experience. So I started with comparison to the banking transfer, which are quite similar because you send from one address to the another. If you would like to ask the user for Bitcoin payment, you can compare mostly to the bank payment because the user needs to do it manually, not like with the PayPal or the .pay services, but he needs to actually go to his own application in a mobile phone or in a website and send manually all the assets. So this is a transaction that I wanted to talk about a little bit because this is a bank transfer that I received from my friend, and I have found a little bit more personal information than I expected from that, and now I understand why Satoshi Nakamoto really suffered from transactions like that, because we are not really close friends with Shimon. You can see it's from Shimon, so that's very first personal information that the bank shows me. His name is Shimon. He lives in Nowy Sącz, That's quite interesting for me because I never been in his place, and I know all information about his banking account. Where does he have his account, and basically the address? That's too much for me, because if you buy something on Allegro or eBay or on Amazon services and you pay with the bank transfer, you need to place there as a bank transfer, as a transfer description, the order number or some kind of your personal ID. And moreover, the bank will share your personal information with whoever you would like to send money, but they will not prove that you send money to the right person, right? If you send a transaction, you can put the data like name or surname, the address are not validated at all, so you can put there just a dot or whatever. That's something what I really do not like in the GDPR era. That should be changed. So the blockchain changed that. But in comparison to the blockchain, you don't have this data. You don't have the sender name or the receiver name, but what is more important, you don't have the description. You don't have the title of the transaction. So how to say that a specific transaction is for you or from the right user? We'll see that in a moment. The same happens with the PayPal. The PayPal works immediately. If the user pays with the PayPal to your account, you will receive the same kind of information. To integrate with the PayPal, you need to just redirect the user to a properly prepared URL address and add some additional information like an email of the user, the amount of currency that you want to receive, and the title, like the order ID, something like that. What you receive is through the return URL or the cancel URL, you'll receive an information that the transaction is confirmed, cancelled, pending, or whatever, but you don't need to take care about actual status of the transaction. What doesn't happen in a blockchain, because you need to take care about all of these things by yourself if the transaction is confirmed. When you say the transaction is confirmed, because the blockchain is not going to tell you that the transaction is confirmed at all. Well, so the blockchain is nothing like that. You need to take care about all the aspects of the transactions, from who to who you are going to send money, without any additional information, because you store only three things: sender date, sender address, which is basically a hash, receiver address, still a hash, and amount of bitcoins that you would like to send. So we created a system that if you like to invest in our ICO, will cover a couple of things. The very first step is request a transaction. We'll generate a totally new address to you, specifically for you, that we will save this address to our database and next to the order and the assets that you would like to invest into our ICO. So we will be able to connect this specifically generated address with your order and with your user ID. That's how we recognize that this transaction is dedicated for you as a user in our system, as an investor. Then you need to pay, like any bank transfer, because you need to take care, as a user, you need to take care about that part yourself. We receive any information about the transaction from the blockchain, and then we confirm that. There is a fifth step after that, which is not necessary, but it is really useful when you operate on a big amount of money. And we, during these ICO projects, because we handle a couple of them, we are able to fundraise about $260 million in a couple of months. So that's quite a lot to secure in the blockchain. And believe me, even if they say the blockchain is secured, but your application is not. So you need to secure all the assets that you have. So my favorite thing, the Steam, introduced for a couple of months the Bitcoin payments, and I spent there like a lot of Bitcoins. buying games. So they introduced that in the same way. They, if you order a game, you pick a game you would like to pay, you had a couple of payment methods there. So the very first step is choose Bitcoin as your favorite payment method. And then they will present you a QR code with automatically generated address, so you can scan it or copy the address from a little bit below, but never rewrite it. If you, that's a funny thing about the addressation in the blockchain, because if you send a bank transfer to some other address, the bank will probably validate if the address is correct or the bank account is correct. If you put, there is a little number at the very end of every bank address that confirms if the address is correct or not. There is a full method how you calculate this number. But here's nothing like that. If you just miss one letter, like that should be uppercase and is lowercase, the Bitcoin will not say you that is a valid address or not, because there is no like address pool available for you. Bitcoin doesn't know which address is already taken or not. It generates all the addresses are available for you right now. And if you send money to a wrong address, it's lost. It's just lost. So it's good to copy that or just scan a QR code to your application. Another step is to present that the transaction is in the pending state, but that happens just after the transaction is sent by the user and before we confirm that from the blockchain. So our implementation of that, and this is in the JavaScript. There's a service that we created was in the PHP, and after that we were implementing the same thing in the C#. So this really doesn't stick to the programming language. So the first thing you need to do is to connect with the node, which is the Bitcoin client. And this is really nice to connect with your own Bitcoin client, because you can actually trust that. There are a couple of many services that provide you the same API through the internet without any additional authentication or authorization. But believe me, if you do not have any legal agreement, and if you have legal agreement you need to pay for the service, you cannot trust it, because they can just publish any block or any transaction and you will receive wrong information from your blockchain. So it's really nice. It takes only a couple of minutes to set up your own node that connects to the Bitcoin. We generate new wallet. We join to the wallet, open it. That happens like the API is quite complicated and undocumented, which is not fine. You open the wallet just like you grab your wallet from your pocket in everyday life. And you create an address. I compare creating an address like creating a new pocket inside your wallet. And you put there a piece of paper that describes like a user ID or order ID. And you know, if you open this pocket next time, you will find this piece of paper and see to which address or to which user or order you should be thinking when you go to this specific pocket. And that's all. You just generate new address in this step. Another step is, of course, the payment. And this happens on the user side. The user needs to use his website or mobile application. I usually use my BitPay application to send assets. It takes only a couple of minutes. And this is another funny part that I discovered. This is how a basic transaction, a really simple transaction looks like in the blockchain. So we have like one hash on the left side, which, is there no, it isn't, laser. We have like one address on the left side and two addresses on the right side. Why two addresses? The first address on the right side is our address that we already generated, but the second one is automatically generated after every single transaction that you send it's assigned to your wallet, to your like primary address, and there are sent all the assets that are not spent in the transaction. So if you didn't spend 1,000 of Bitcoin, it will be moved to a new address. So the anonymity is provided with that. You cannot say how many transactions comes out from a single address that if you even recognize that the address is assigned to some person, to your friend or something like that, because he paid to you from this specific address, you will not be able to find out which transaction is the next, because the address will be totally new. But then some problems came out, because we needed to grab transactions, and we are at this point we are able to actually see all the transactions from our investors. But our investors were really clever people, and they started to messing with the transactions. So that's what we received. A transaction from 5 different accounts to another 5 different accounts, and for first 4 transactions were accounts were ours. So that can happen in the blockchain, because if you do not have on a single address enough assets, the blockchain automatically will find your another address that you can send the assets from and add to the transaction. So you can send money from 4, 5, 6, or 1 address to another address. But they somehow managed to send it, a single transaction to a couple of addresses which were actually the same. So you cannot just find a single address in the receiver field in the API. You need to go with the for each iteration through all the addresses and do the same thing for all of them. So another point, the third step in our process was to get an information from transaction. We knew we already had saved all the addresses in our database, so we basically could go through all of those addresses and just check if there are some transactions ready for us or something like that, and mark any transaction that was ready as done, and don't see any other transaction. But that's not how it works, because after a couple of months you have like 100,000 or even 1 million of users, and if you like to every 10 minutes go and iterate over every single address and check the transactions, if there are any new transactions for you, that will not work perfectly. So we decided to just watch for the lastly published block in the blockchain and go through all the transactions that are included into the last block and just check if there's something interesting for us, if there is some transaction specifically generated for us. So the simplest function for that, and it doesn't require any authentication or authorization to your node, to your client for the blockchain, is just get last block from get block by hash. That's described by the API, but the thing is, what was the hash of the last block? So the blocks, as I said, go one after the other. They do not have only the hash as a recognition number, but also the number on which place do they stand one after the other. So the first block is the first block, the second block is the second block, and so on. And they all have own hashes that you can recognize, but you can still get the hash from another function in the node. That surprised me that you do not have any function in the API that can get you a block from the number from the block index, but you need to get the index and the hash number from the index point, and then get the block from the hash point. So we iterated, we saved in the cache like the lastly watched block, and went one after the other until we reached the highest block available in the blockchain. And in the blockchain, you have a list of, in the lastly published block, you have a list of transactions that you need to still call and check if you have saved in your database any receiver from that block. What you receive is, that's the index of last block. What you receive is the confirmation of lastly published transaction, and this is only one confirmation because you don't have like a status of a transaction in the blockchain. You have only a number of confirmation. When the transaction is included into last block, you have one confirmation, which is not enough because you can publish another block on the top of the last published block, as it might be a corrupted block. So we decided to include a couple of thresholds because from time to time you don't want to make your user waiting for the confirmations. So we decided that every investor that invests less than $100 into our ICO will wait for about one confirmation, because even if the last block is corrupted and somehow somebody unsecured the blockchain there, we are able to manage to lose $100. A transaction below $5,000 needs 2 confirmations. And the transactions that are above $5,000 require more than 3 confirmations. 3 confirmations in the blockchain is just enough to say your transaction is fully confirmed and secured. So you need to put a really good balance between the time that the user is able to spend on waiting for the transaction confirmation and your trust in the blockchain. That's why we created those thresholds. And the 5th step that is not required in the process to confirm a transaction, but is really nice, is to move your assets to the cold wallet. When you create a new wallet in the blockchain, you usually receive a private key. The public key is globally available for you in the blockchain, but the private key is something like a password for you that you need to save and take care about. So what we did is we disconnected our computer from the internet and created in the blockchain a new address, a new wallet, which were not connected to the internet at all. And we started moving all the assets, or 95% of the assets, from the old address or from the addresses of the users to the newly generated address that was never connected to the internet. What we call, and you call it as a cold wallet. You are able to get the assets from there only and only when you connect this one computer to the internet. Before that, it's not possible because the password you created was never published to the internet, so nobody can own this money before that. What is the disadvantages of that approach? You can always lose your computer, damage that, destroy something like that. If you have more than this amount of money, like $200 million, that's a huge risk. So we managed to create a couple of cold wallets and send that to a couple of them. But the question is what they buy. If the investor invests into your ICO or into a company, what they buy? They buy tokens. And the tokens is totally different things from the Bitcoin. It's implemented in the Ethereum block ledger. The transactions basically work in the Ethereum like in the Bitcoin ledger, so that's nothing to talk about, but the tokens are something new. They are based on the smart contracts you probably heard about. The smart contracts are like little programs. I describe them like classes inside the Ethereum that can execute some specific code in the ledger, or can read data from the ledger. One you need to pay for, and one is totally free. The integration with with the Ethereum goes through a couple of applications. If you would like to use the command line, is the best client for me is the GET client, but we use that only to serve the API for our applications. But if I would like to develop some new smart contract, I usually use Mist, and the Solidity is the programming language that you use for the smart contracts in the Ethereum. That's how a single smart contract looks like. It can do a couple of things. A lot of examples that you can find in the internet are mostly about sharing the salary that the owner of some company can send money or ethers to a single address. For every smart contract you have like generated new address, and your employees or your workers can get those money from for themselves just by calling this address with a specific function, like send me some salary or something like that, and you need to take care about anything. But that's a really hard task to implement a good smart contract. Even like really experienced companies failed to secure all their smart contracts. And if you send a smart contract to the ledger, you can never change it. So if you find a bug, like we really had to test properly our smart contracts for the tokens or for the coins, because if once you publish that, you can never change that. If you find any bug or security issues, some other thing in your smart contract, you cannot update it. You cannot move your assets from one smart contract to the another. You need to firstly find a way to implement properly an update function for that, which is not easy, believe me, and which is not secure. And to be able to just somehow copy the data from the old smart contract to the another. That happens also to the ledgers or the blockchain itself, because there were plenty situations in history that the blockchain, that the Bitcoin wanted to change something in the protocol, like extend the amount of data that you can put into the block, because right now it contains, a single block contains only 1 megabit, which is more or less 2,500 transactions in a single block. What is 2 transactions per second, which is not enough. They decided to extend this limit to 5 or 10 megabits, or then they finished into 2, which was called as a SegFault 2.0 change. But they never did it, because to update something in the blockchain, you need to update 99% of the clients in the blockchain, what never happened. So that's how in the user interface a single smart contract looks like. Let's go back for a moment. So the structure of the smart contract is quite similar to the class that you can find in any other programming language. The contract is keyword. I treat it as class. The structs, the fields, private and public fields are also available, and you have functions. The functions can either read from the smart contract or from the ledger, or write something to that. Reading is free, because it doesn't require any computation power from the blockchain. But if you would like to write something to the blockchain, you need to pay for that. Not a huge amount of money, but multiply that for 1 million users, and you will find a right number that you need to secure on your assets. So that's how it looks like in a user interface. You have a couple of fields. On the very top, which is really interesting, is our address of the smart contract. If you push a smart contract to the ledger, you will receive an auto-generated address to that. You have a list of functions you can execute. The reading function are executed immediately from the smart contract, but if you would like to write something to the blockchain, you need to wait for the next block. Because the block, if you write something to the smart contract, it will change your state. You have a couple of functions on the right side that transfer ethers or tokens to the smart contract and the execution button. So, if you like to, the tokens or the coins smart contracts has a specific interface that you can implement on your site, which is called RC20, and basically at this point you are able to manage all the things on your assets or on your smart contract. If you push something like that, your smart contract which implements this kind of an interface, the Ethereum will finally recognize you as working tokens or working coins, and you will be able to manage transactions with that. What's funny, this kind of a contract doesn't need to allow to accept ethers as a payment method. You can just store there some kind of information, data, or tokens, and spread it through the blockchain. But it doesn't require you to have any ethers on your address. And from time to time, you can block it by a specific function, but it can be you can break it. That's one of an implementation, possible implementation of smart contracts, which is not secure, because we have found that if you would like to write a really fine smart contract, you need to learn how to do it and how to do it securely, because you cannot change anything. There is a really fine site which is called Eternal Zeppelin Solutions, which delivers 30 or 40 different smart contracts that can be broken in one or the other way. There are some mistakes made in the contracts that can be can change the contract behavior. This is a contract where you have a specific amount of tokens available for you as a user, but you can unblock it or sell it after 10 years. What is funny, the lock tokens function doesn't work properly, so you are able to break the function and get the tokens right now. The Parrot company, which is one of the leader in the smart contracts world, did a couple of mistakes in their history with the smart contracts that was able to handle billions of dollars. Where like a year ago there was this case where somebody just removed the contract from the blockchain, and that was not they were not able to create it again or get new smart contracts for that, because it was so hard. They even were talking with the Ethereum board about copying the whole Ethereum ledger to a new place and switching the Ethereum to some new version where they will fix their contract, but it never happened. They just lost the money. So we have everything on place. We can take transactions, invest money, we can even spread the tokens, everything is okay. But then we opened our documentation or the requirements from the user, and he said, hey, I said to you the user should be verified. Yeah, we have a registration process, login process, email confirmation, something like that. The user is verified. No, the user is not. You are in the financial world. So verified means something quite different than verified in the usual application. The user is verified when we can say, hey, Dan, you're Dan, I know you. I know how you look, where you live, and that you can actually invest with us. That's the US law that we need to take care about, because that's one of the most sophisticated financial law that we can imagine right now. So that happened to me also on the other websites. If you would like to buy bitcoins for testing purposes, like you need $100 in bitcoins just to test if everything is working on your website, you can switch to the testnet, because the Bitcoin has a couple of modes that you can switch within. You have the SimNet, the simulation network, that you can publish any block or mine any block, publish any transaction whenever you want, but the block there is available for you and only for you. On your local machine, it doesn't connect to any network. You have a test network where all the tokens or all the bitcoins are totally free for you. You can generate new bitcoins or get from some website, and they will send you like 50 bitcoins just for free because that's the testnet. They in the past, many people were selling the test bitcoins for actual money, so they needed to close the first version of the testnet and open a new one. So now we have like a third version of the testnet, and you have the mainnet, which is the actually main network that you can manage on. So finally, you would like to test everything with the mainnet. And whenever you buy bitcoins, so somebody in the internet, and probably most of the applications or the exchanges system in the internet, would you like to ask you to scan your ID? Would you like to scan your ID and send to somebody in the internet? I don't, but you have to. Basically, you have to. And moreover, if you are operating on the US, with the US environment, you need to not either scan the ID, which is called in their know your customer, but also to scan an accreditation as an investor. You need to get more legal papers from them. For right now on, and this is the only advertisement I have to you right now, is the global ID, which is a global identification process through the internet. We are developing that right now, which describes your identity, where you can log in and register yourself without scanning any ID or passport or your driving license, because you can connect your global identity, internet identity, with your bank. If your bank already know about you, that you are you, and you can and they already scanned your ID, then they can say your global ID is okay with us because we've seen you and we scanned your ID, so that's totally okay. So the next company, whenever they ask you for your ID, we can say we have a bank that already confirmed that with your ID, so you don't need that. If you need any other information, please ask the user. We will create new record for you, but you don't need to scan another ID. So that's fine if you connect to your bank because they need your ID anyway, but you don't need to send your passport or the ID to the internet. Yeah. What do you mean? If they, how do they? How do they prove the ID from another bank? This is called what we call a trust factor, because we, as a global ID company, say we trust this bank, so you trust this bank too. If they say that they are okay with your ID, then we share this information with other companies, and they need to trust the bank too. To sign a legal paper with us or legal agreement, to start working with us as a global ID, you need to actually sign a legal agreement. But this bank should be connected to the global ID. This is more complicated because you have like your own hash you need to give to the bank, and the bank has own hash generated by us and we find a pair of those hashes, and after that you can get the data. We don't sell data like that. Yeah. Okay. Yes, It can, because we store all the information about your identity that we get from the bank or other services. So you have your own private key that you can manage, and only you can manage your information. So whenever you connect to our application, we are pretty sure that the user that is connected to our application is the user that we already accredited or verified. Somebody needs to take specifically a single device like your phone needs you to know your password, your private key, and other stuff. We really secured it, believe me. And all the information in the database is hashed by the private and public key. So even we don't have an access to your private data. Another stuff is, as I said, if you invest more than $2,000 in the US, you need to have an accreditation from the government. It works more or less like when you register your company in the civil office. So you get those papers. We need to scan it and confirm that you are actually investor in the US. We cannot accept your money if you are not an investor, accredited investor. There's something what is called anti-money laundering system, which you should still provide, because there is a huge it is a huge thing in the blockchain world that people say you can money launder your assets through the blockchain. So if you fundraise money from with the blockchain, you should really secure that. But that's totally a topic for a different presentation, including the artificial intelligence and some other requirements that are quite complicated. But in this point, I would like to just point that it's necessary to take care about that and implement. You need to know you have like a blacklist of users or that convinced people from different countries. You have blacklists of the countries that prohibited to using blockchain at all or the cryptocurrencies. So you cannot accept any money from China or from North Korea, and a couple of more factors. Another system that we created was the exchange currency, which is pretty basic. If somebody wants to buy some cryptocurrency, he needs to pay some money. Then the question is, how much money does he pay? And you can find a couple of exchange systems, like person-to-person, where you buy cryptocurrency from other person, and you buy whatever they would like to get from this transaction. Exchange platform, which is quite slow when you like to pay and doesn't operate really fast on the market, and trading system, which basically is something really fast, which operates on the market really fast and really quick. If the Bitcoin price drops, the price in the trading market should drop too, which we will talk about now. Through the past 7 days, the price of the blockchain dropped for about 30% or something like that. So just imagine you run a trading company and your concurrency is here, but your price is a little bit higher. So basically somebody can get your money by buying Bitcoins from the another company, which is pretty cheap, and selling it to you. So that's a huge challenge to manage your price and compare it with other companies, with your competition. And to have it right on time, because if the Bitcoin price drops down, you will be probably able to lose some money. And the Bitcoin price is based on a couple of factors. This is well described by the CoinDesk application. This is the network factor. How much users can pay for the for a single Bitcoin. It's based on the price from the history, from the exchange rates, from the person-to-person applications, from the exchange applications, on the social information. You need to watch what happens in the newspapers. If there's any news that can collide with your Bitcoin price or something like that, and developer factors, which are basically all the artificial intelligences or codes that you need to take care, that you need to implement to put all of those things together to be sure that your price is correct for this time. And that's all what I have for you today. Any additional questions? Cryptocurrency from one trade to another. The cryptocurrency is shared between trades, so if they do not allow it, basically the trading system or the exchange system should accept your address or should generate your a new address for you, and you should be able to generate a password for that. So whenever you would like to move to other trading system, you just paste there your address, or don't do it, password. Some of the trading systems require to put there your password. So the information is spread through the blockchain. There shouldn't be any things that blocks you from moving your assets from one service to the another. I know that some of the blockchain, some of the services generate for you the address and don't give you the password, but you can basically send a new transaction with your cryptocurrency to your personal address and just move this address to the another trading system. Any other questions? If not, thank you for coming.